Assalamualaikum warahmatullahi ta'ala wabarakatuh, and a very good afternoon albeit to all the participants of RUG Conference 2020. And I am Hidayat from University of Science Malaysia Health Campus, Kubang Kerian, Kelantan. I'm here today to illustrate to you on how we can use the Ordinal Logistic Regression using R. And subsequently, I will show you on how we can visualize the model to make the interpretation a little bit easier through the model plotting. And as many of us, the beginners of art, found that it is difficult and sometimes confusing to interpret the statistical model, as it is dealing with huge amount of output and sometimes huge amount of numbers. And through plotting, we can make the interpretation of the statistical model a little bit easier. And the title of my presentation for today is Visualizing the 10-Year Fatal Cardiovascular Risk Modeling Among Malaysians Using R. So I'll be divided the presentation into two parts. The first part cover regarding the background of my study, which I will cover the introduction, the methodology, and also objective. While the second part of my presentation, I will touch on the demonstration of performing ordinal logistic regression using R, which I will cover most of the statistical steps in the analysis. So let's go to the first part of my presentation. As introduction, as we all know that the cardiovascular disease is the #1 top killer in the world, as it contributed to 17.8 million deaths annually. And it is approximated that 31% of all global death is contributed by cardiovascular disease alone, and more than 75% of this CVD death occur in low and middle income country. Whereas in Malaysia, we face the similar problem, where 1/4 of all hospital deaths in Malaysia are contributed from the cardiovascular diseases. And 4 in 5 of hospital admission are males with heart attack. And the average age of getting heart attack among Malaysians is 58.5 years, where 1 in 4 of these patients are getting heart attack at the age of less than 50 years old. This is very concerned and very worried situation for us, Malaysian. All right. And to estimate the cardiovascular risk, we use the global risk calculator. It was developed by the public health team in Harvard University in 2015. It was the latest CVD calculator that was developed, and it can be specified to each country, unlike other CVD calculator. So make it superior than the previously developed CVD risk calculator. And for the cardiovascular risk, the outcome of the global risk calculator can be divided into two main outcomes. The first one is the fatal global risk outcome, and the second one is the non-fatal global risk outcome. And for this analysis, I will only focus on fatal global risk outcome, in which it is defined as the probability of having future fatal CVD events in relative to the fatal CVD events in the initial recalibration process for specific country application. And for today's presentation, the objective is to model the 10-year Malaysian CVD risk score as a function of age adjusted to the ethnicity in Malaysia. And we move on to the next part for my presentation, which is the methodology. The data source of our analysis today is from the 2015 National Health and Mobility Survey, and the fatal global risk score is further stratified into 4 ordinal outcomes, in which it will be stratified into the low risk as defined as less than 10%, high risk as defined as more or equal to 10%, more or equal to 20%, and more or equal to 30%. And for the statistical method, I will use various statistical R packages, which are the Ordinal, Tidyverse, Heaven, Effects, GT Summary, Forecast, Deployer, and the Broom package. the detail of this use of various packages will be explained in the analysis part later. And to perform the ordinal logistic regression, we will use the ordinal logistic regression to examine the relationship between the age category to the 10-year fatal global risk score of nations. And to perform the ordinal logistic regression, we will use the cumulative link models or the proportional odds model from the ordinal package, which are very excellent in dealing with such ordinal data. And I will also use the polar function from the mass package in combination with effects package in order for us to visualize the model through plotting. And that's the end of the first part of my presentation. Let's move on to the demonstration in R. So let's go to my R Studio. And first of all, we have to prepare for our analysis by loading all sorts of packages. I will load the ordinal data to perform the modeling, and I will load tidyverse for data wrangling, brooms to generate more pleasant modeling result, and also the GT summary to create a presentation ready table. And the last two is the player and also forecast for factor reordering. Okay, let's run the chunk. It will take a little bit time for that. And then secondly, we have to read the data. I will read the data name data RLG globaris.csv and make it as object name globaris. All right. And after that, we will use the glimpse function to have our overall look of the data set. Okay, let's run the chunk. And as we can see here, we have 9 variables with 7,660 observations. And most of the variable is in the character form. And we will convert this character variable into the factor variable later. All right. And then we will use the summary function to examine for any missing data. And fortunately that we have no missing data in this data set. All right. And next step is we will convert the character variable into the factors variable, okay, by using the stir function and s factor function. And then we will select the intended variable in this analysis from the globaris and make it a second object named globaris2. And we will use the stir function again to have a look what we have done. All right, let's run this chunk. Okay, if you have a look, initially the class of the variable is in a character form. After we transform, we have 3 factor selected, which is the ethnicity, the age group, and the fatal outcome of the globaris, in which it is in the factor classes. Okay, and then we have to reorder the factor variable into a meaningful order so that the reference group will be more concise and meaningful. All right, so we will order the factor variable for ethnic and also for the fatal categorical outcome of globaris. All right, and then we will have the summary of globaris2. And we can see here, we took Malay and age 40 to 44 and the low risk group of the fatal category to be as our references in our analysis later. All right. And now we move to the estimation part where we will fit the model using the proportional odds model or the cumulative link model. So where we call the CLM function with fatal cat as the outcome category, age category as factors, and ethnic as the covariate using data global risk 2, and name the model as global 1. All right, and then we have to summarize the model using summary function. Okay, let's run the model. All right, if we can see here, we have the threshold coefficient, and we have also the coefficient. All right, and to have a nice output, we can use the tidy from the Broom package, applies to the global 1 model, and we will have this type of output. And if we can see here that the age group is in positive value, and the ethnicity, especially the Chinese, Indian, and others Burmese, is in negative value. So what does it mean? It means that older age and other group are associated with higher categories of outcome, whereby the Chinese, Indian, and others Burmese ethnicity are not associated with higher categories of outcome, in which it is served as a protective factor. And if you can see in the tidy function, there is no odds ratio, and there is also no confidence interval. We can generate those items using tidy function and add the exponent shape and confidence interval setting and set it with a true function. So we can have a look when we run the chunk. It may take a few times to produce the result. All right. Okay, we can see here the age group. The older the age group, the higher the odds ratio. And we can see that the Chinese, Indian, and others Burmese have a protective odds ratio, and the others ethnic have a risk to develop severe cardiovascular risk in the future. Okay, the older age is associated with higher odds of having severe CVD risk when adjusted with ethnic variable. And when we control for age category, the Chinese and other Burmese have 0.51 and 0.49 times lower odds to have severe CVD risk respectively. So this I get from 1 minus the odds for the Chinese, Indian, and other Burmese. And after that, we can use the TBL regression function from the GT summary package to simplify the model in a presentation ready table for easier interpretation. The TBL regression function is highly customizable. You can customize the label, you can customize the header, you can customize, you want to bold the header, you want to bold the labels, and you can also customize the digits. So it is very helpful for us to create a presentation ready table. So we can run the chunk using the TBL regression function. All right. In this case, we will edit the table and modify the header to a variable, and we will bold the labels. All right. You can see here, it is a very nice regression table where you can also export. You can also knit this table to various formats, to PDF, to Words, to Excel, and you can further improvise your table later. All right. Next, we move on to the inferences, where we compare the previous model with a newly developed model using the likelihood ratio test. Okay, so we will use the CLM function again from the Ordinal package to perform the model without covariate and set a test to chi-square and name it as Globo 1B. So when we run the model, after that we will compare the both model using ANOVA function. All right. So we will do that. When we do that, we can see we have the IC, the AIC. The model comparison can be done through comparing the AIC with, we will look at the p-value. So if the p-value is less than 0.05, if we set the significant level at 5%, so looking at this p-value, it can say that our model is statistically different with a p-value of less than 5%. Okay. All right. Next is we will do the prediction. Okay, to predict the probabilities of IS observation to fall into which outcome category for model with a new data. So we will create a new data first, and we will use the expand grid to create a new data of class data frame. So we will use the expand grid to create the new data first, and then we will see the new data. After that, we will predict the probability for a new data in which the observation will fall into which outcome category, so that we can make it tally with the previously developed model. All right. We have to remember back the outcome of the fatal global risk. We have low 10%, high 10%, high 20%, and high 30%. And let's do the prediction using the linear predictor. Okay. All right. Let's run the chunk. You will have a long list of data, but don't worry, we will use the cbind function, okay, to make the results better. All right. We use the cbind function. Okay. We can see here, all right, for age group, for younger age group, it's classified most of the observation into the low risk less than 10%. And for the older group, it classified most of the observation into the high risk group. And it is the same for all ethnic. You can see here, Indian, younger group. Most of the younger group will be in the low risk group, and then most of the older Indian will be in the high risk group. All right. Okay, it is the same for other ethnicity. So what it tells us that our prediction is parallel with the previous model developed, where it shows if we go back to the previous model, the older the age group, the higher the odds, and the higher the odds ratio to have a severe CVD risk. All right. So looking at this, a lot of outputs, a lot of number, you will be confused on how to interpret the model. However, I will later show you on how we can visualize the model. But before that, we have to check the assumption for Ordinal Logistic Regression. Okay, we will use the Nominal Test from the Ordinal package in order for us to check for the proportional odds assumption. All right, let's run the chunk. Okay, the function tests the ordinality of the covariate. In this example, the ethnicity shows that the assumption of proportional odd is presumed. The p-value is more than 0.05%. If it is less than 0.05%, then the assumption is violated. All right? Okay, next, the most interesting part of my presentation, we will visualize the global risk model. All right? So in this section, we will use the polar from the MES package, and we will also use the effects function from the effects package to plot the model. So first, we fit the model using the polar. We run the MES library, and secondly, we will create the model using the polar. The same setting as the previous one. All right, then we summarize the model. Similar thing, we get the coefficient and intercept. Previously, we have threshold coefficient. All right, and then now we will run the effects library, and we will plot the model, which consists of age category only, and we will also plot the model in combination with the ethnicity. All right. Okay, let's run the chunk. Okay, if we have a look at the plot, okay, it is rather easier for us to interpret. You can see here at low risk global risk outcome, it is highest in the younger age group, and for the high risk global risk fatal outcome, which is high more than 30%, it is highest among those who are in the older age group, right? And when we combine the effect of age category then the ethnicity, we can have a better graph in the, all right. We can have a better graph here. All right, you can see here, for all ethnicity, at older age group, they have a very high risk to develop a high risk global risk fatal outcome in the next 10 years, okay? Similarly here, for the low risk outcome, it is higher among those who are in the younger category and lower for those in older age category. All right, so using the plotting, you can easily interpret the model. All right. So that's all for my presentations today. I hope you can understand that. If you have a problem or inquiries, you can always email me at drchidayat@student.usm.my, and you can have a look to my source of coding at my GitHub account. Okay. So thank you for your time spending here.